Section 1.3 is titled Linear Functions, but all we're really concerned about in this section is the slope of a line. The slope of a line, usually denoted by the small letter m, is defined as the vertical change of the line over the horizontal change of the line. So in the particular case of this line, the vertical change between the points 1, 0 and 4, 1 is just 1 unit. And the horizontal change between the points 1, 0 and 4, 1 is 3 units, giving us a slope of 1/3. Normally, you won't be given the picture of the line. You will just get 2 points, and you'll have to find the slope from them. What you're going to do in that case is use the formula for the slope of a line, which is y2 minus y1 over x2 minus x1. So the first thing you're going to do is designate one of these pairs, x1, y1, and the other pair, x2, y2. And it does not matter which pair you pick to be which. So plugging into the formula, we get y2 minus y1 over x2 minus x1 equals 1/3. Now, let's try to find the slope of the line between these 2 points. So just like before, we designate one pair, x1, y1, and the other pair, x2, y2, and then we plug into our slope formula. And we get y2 minus y1 over x2 minus x1. And remember, those double negatives are the same as additions. So we get a -2 over a -8, which gives us a slope for this line of 1/4. You're also going to be asked to find the slope of a line when the points are given in function notation. And remember, in function notation, whatever is inside the parentheses is your input, or your x value, and whatever's outside is your output, or your y value. So you can think of these points in function notation as just regular ordered pairs. And then finding the slope is straightforward. Designate one pair x1, y1, the other pair x2, y2, and plug into our formula. So y2 minus y1 over x2 minus x1 gives -1 over 6. So we have a slope of -1/6. Let's try a couple more that give us somewhat special cases. So once again, we designate one pair x1, y1, the other pair x2, y2, and we plug into our formula. So we get y2 minus y1 over x2 minus x1, or 5 over 0. Okay, remember, anything divided by 0 is undefined. Let's look at something that's similar, but not quite the same. Let's find the slope of the line that passes through these 2 points. So again, designate one pair x1, y1, one pair x2, y2. When we plug it into the slope formula, we get y2 minus y1 over x2 minus x1, which is 0 over 4, which is just 0. So remember, when you're doing these, if you get a 0 in the denominator, your slope is undefined, and if you get a 0 in the numerator, your slope is just 0. The last thing we're going to do in this section is find the slope and y-intercept of lines when we're just given the equation. And to do that, we'll want to get the equation in what we call slope-intercept form, y equals mx plus b, When you get the line in this form, whatever is in front of your x is your slope. Whatever number is out here, or the constant, is your y-intercept. So in this particular case, we have a slope of 2 and a y-intercept of 0, 7. Let's try another one. It's in slope-intercept form, so this one's fairly simple. The slope is whatever is in front of the x, and the y-intercept is your constant. And you'll note it doesn't matter which order your equation's written in. As long as you have the y by itself, whatever's in front of the x is your slope, and the constant is your y-intercept. Now, many times you're going to be given the equation in this form, and you have to get it into slope-intercept form. So what you're going to do in this case is move the x over to the right-hand side. And I'm just going to move this term over, and I can do that as long as when I cross this equal sign, I change the sign. And then what I have to do is divide everything by -4. So that gives me y equals 1/2 x minus 3/2. So now that I'm in slope-intercept form, my slope is just whatever's in front of the x, and my y-intercept is just my constant. Let's try a slightly harder one of these. And now I have two terms I need to move over to the right-hand side, this x term and this constant. So I'll just move them over. And remember, I'm allowed to just move them over as long as you remember to change their signs when they cross the equal sign. And now I just divide everything by 6 and simplify. It's in slope-intercept form, so whatever's in front of the x is my slope, and the constant is my y-intercept. Now you have two special cases, and they occur when one of the constants is missing, either the x or y. In this case, we just have the x. And this you're just going to have to memorize. When you just have an x, you have a vertical line, and the slope is always undefined. If you just have an x, you do have an x-intercept, but you do not have a y-intercept. In this case, the x-intercept is -6, 0, and we do not have a y-intercept. Okay, similarly, if you just have a y, the slope is always 0. And this one will have a y-intercept, but it will not have an x-intercept. So in this case, the x-intercept does not exist, and the y-intercept is 0, 3.